So today we're moving on to lesson 10.8, and yes, I'm aware that the lesson plan is incomplete right now. There will be more problems coming up in a second, but for now, we're ready to do parts of this lesson. So I start with the definition of the natural logarithmic function. So why the natural logarithmic function? Because it has a lot of real-life applications, and you'll study those as you move on to calculus and pre-calculus, or I should say pre-calculus and then to calculus. So, what is the natural logarithmic function? The natural logarithmic function is the function, the logarithmic function, that has a base of e. So, just like a common logarithm is a logarithm with a base of 10 and can be written in a different way, so can log of x with a base of e. A different way of writing this is just f of x is equal to the natural log of x. Since this is a logarithmic function, its graph is very similar to those of other logarithmic functions. It will pass through point 1, 0. The graph will look like so. So this is y equals natural log of x. Its domain will consist of numbers, real numbers that are positive, and its range, as you can see from here, it goes all the way down to negative infinity and all the way up to positive infinity. Its range is all real numbers. We can give an extra credit question right now, so extra credit. What is the inverse function of f of x equals log base e of x, or f of x equals natural log of x? So we've spoken about log of x with a base of e, but we haven't even talked about what is e. So what is e? The number e is defined to be the limiting value of 1 plus 1 over n raised to the power of n as n becomes larger and larger. Very soon we're going to take our graphing calculator and we're going to see what that number e is. But in your book, you are told the number e is approximately 2.71828. And just like the number pi, the number e is also irrational. So it goes on forever and ever. There is no repeating block of numbers. So let's take this definition and our graphing calculator and let's see what happens. So we're going to move on to our graphing calculator. We're going to turn it on. We're going to go to y equals, we're going to clear whatever scary things we had there. And we're going to go 1 plus 1 over x raised to the power of x. We're going to go second, table set. We're going to put it on ask, which it already is. And then we're going to go second and table. So for our table, we're going to start by entering 10. We see 2.59. 10 is not a terribly big number. 100, 2.7048, 1,000. So now x is becoming larger and larger. We're up to 2.7169, 10,000, 2.7181. Remember, if you look on the board, what did we say e is? 2.71828. So 10,000, our approximation is pretty good. Let's input a few more numbers. We're going to now look at 100,000, 100,000. We get 2.7183, 2.71826. So we're off right now. by about 200,000. So our approximation right now is good, and we're only up to 100,000, which is not terribly big. Let's try 1,000,000. You notice that this has not changed, and now our approximation is exactly 2.71828. So yes, the number is increasing, but it's increasing very slowly. So that is what the number E is, and this is how we obtain it. Okay? We'll stop right here and continue the lesson with the properties and the laws.